Hey guys, 2017 Chevy Trax with a no blower operation complaint. History of this was it only had blower speed on high from what I was told. The resistor was replaced, which is actually a module, and everything worked fine for a couple of weeks, and now nothing is working at all. I guess the owner also complained after the blower was working that he had no heat. So we may have multiple issues going on here, but our focus today is no blower controls on a 17 Chevy Trax. There are two versions from when I looked at the service info before we got here. Two versions of HVAC controls. There's a manual and an auto. There is no auto button. There's no temperature display that I'm seeing. So this is suggesting to me that this is just a manual system. The automatic AC system used a pulse width modulated blower motor. The manual system has resistors, but on both of them, the resistor assembly, if you want to call it, is a electronic device too. There's a module inside of it. All right, so engine codes, we have O2, fuel trim, evap, intake airflow, stuck lean O2. I'm not worried about any of that for this one. Body controller, we want to focus on the BCM. BCM is in control of the main relay, but nothing related here, it looks like, on the BCM, just tire pressure sensor stuff. In my HVAC system, there are no codes. So we have HVAC manual, single zone. That's going to be us too, probably. And then we have manual control, heater only. We're just going to pick that right now. I know there's no codes in the system. I'm interested in blower, switch, and control. So that's just ignition voltage and battery voltage on the HVAC system data. Sensor data, let's see what we got. Got engine coolant temperature. Not a whole lot here. HVAC faceplate data. Just have rear window defogger. Just gathering data here, guys. Bear with me. So not much help in these three data lists. What functional tests do we have? Illuminate all indicators. Let's turn them. So there we go. That's just the module itself. Bidirectionally, I made everything light up, and then I should be able to turn them off. These ones are staying on. They're probably on all the time. There's your bidirectional control. This is just module communication here, which is helpful depending on, what we have going on. So not a whole lot in here helping us with the blower controls. It's a manual system, that makes sense. So we need to do manual checks down at the component. We need a wiring diagram so we know what we're doing. All right, HVAC control module. Okay, blower motors here. This is all a ground side switch circuit based on that ground right there. All of these wires from this point over are going to be grounds. And what you have is we're varying resistance to ground with this resistor. Okay, Pete said he changed the resistor, not the HVAC control module. I was thinking they were the same. They're not. The switch is in the HVAC control module, which is this guy right here, right? This piece, and as you saw me bidirectionally turn things on, this is the face of this is the HVAC control module. The switch is a manual switch, but it's part of the control module. The resistor itself is separate from the blower motor, okay? And then that's all on the ground, and then this violet and brown wire would be your feed to the blower motor, and I'll show you that on the next page. That is relay controlled, right? So it goes to a relay. So there's like a 40 amp, there's a 40 amp fuse that feeds this side. It's back on the other page. And then the control side of the relay up here is externally grounded all the time. And that means this is a power side switch circuit. So where that goes is our control, and that is the BCM. The BCM then switches that relay on to provide power to the blower motor all the time. Like as soon as you turn the key on, I believe that would be active as soon as you turn the key on, pretty sure. And then there's a separate wire that we're also then, when the BCM turns the relay on, you see this blue wire. Let's go on the next page. It's also going to switch something else on at the same time. And the way that they have this listed It's this guy right here. It's listed as ignition 3 voltage. We're basically triggering this HVAC control module, a 12 volt. The same time we're using that 12 volt to turn on the relay. So that's essentially the short version of what we're dealing with here. Blower motor, we're gonna do some checks right at the blower motor first. I want 2 voltage readings here and here is really what I'm going after. This is like, there's one bolt back here that like, I can't get my other hand in there. I got the socket and the extension on it without the ratchet, but then I can't find it with the ratchet on there. So frustrating. It's too loose for the ratchet. It's too tight for my hand. I'm not at the point of throwing things yet.
It comes quick though.
It does. It's coming. Not the bolt. Me throwing things. Oh my goodness. You're up. I got it most of the way out.
The back one?
Yes. This is how you not throw tools. You get somebody else. This is a legit thing to do. When you're in the shop, you're working next to somebody, and you're ready to start throwing shit, just stop for a minute. Ask for some help. If you got a good team working next to you, someone's gonna help you. Usually the hand comes over and it's like, see, real quick and easy. Did not take long for me to get frustrated on that. Did you get it? My man, just like that. Pete's the man, thank you, Pete. That keep me from breaking the customer's plastic cover. We'll just use our digital meter here. All right, I'm on the 1 pin. Can you see the connector? I'll use your camera to move over, because otherwise my head's gonna be in the way. If you can zoom in on that, yeah. So that's 12 volts on that wire. I'm not sure what color that is offhand. Looks like brown and blue. Well, this is hard to do with the camera. Everything's back. I can't do it. I need to get my head in there. That's the other wire. So what that's telling me is there's no ground for this right now. And up here on the switch now, no changes. What we do know though, by the 12 volts to the blower, is we know the BCM is sending its signal to the relay. We know the relay is turning on, and we're sending voltage down to this blower motor. So that much we know, but I'm missing a ground. So no ground is controlled through the blower motor resistor, and then through the switch, and then to a ground that's under the center console. I smell something burnt, so it might be a burnt resistor. If that's the case, we have to worry about blower motor amperage, the motor itself, and then also if this has a cabin air filter where the cabin air filter is completely restricted and we're not getting good airflow across the resistor. That's what keeps them cool and keeps them from burning up. But that's what we're looking at here. I can provide a ground for the blower, but I need to make sure that I know which of the 2 wires I'm grounding. So I'm referring back to the diagram real quick. The violet brown is my feed. The white black is my ground. So right now I'm on the white black wire. Let me grab my power probe. So down is ground, right? I turned the buzzer off. Up is power. I don't want to give it power. I want to give it a ground. Okay. 12 volts. Okay, so we know the motor's working. What we don't know is airflow in any of that yet. We're focused now on the resistor itself. So the white black we know is not being grounded. In the high speed, which is 4 is gonna go through, you see the switch up here. When we move that switch down to position 4, that provides a full ground to the blower motor. And up here, we're already on 4. So what I'm interested in is the second white black wire. It looks like pin D. I want to know the voltage level on that white black wire is going to tell me really everything I need to know. I'm gonna, from this point, so I don't have to fart around with the door jamb and this ground, we'll use the power probe ground, which I really like with this tool. That goes right to battery ground now for my lab scope. Yeah, you can see the two white blacks are a little bit discolored, but it would be from left to right. Yellow brown is A. Looks like blue yellow is B. The first white black, which is C, is the ground that we already tested. So third one over, we're testing that wire up at the blower. I'll do that one first for you guys. That one, what you're gonna see is 12. You're gonna see 12 on that too. Unless there's an open between the blower resistor and the motor, which is not likely. I got 12 volts on that. That's the same wire, just from the blower motor down there. Same wire. The next wire over is gonna tell me everything I need to know. Well, at least a big part of what I need to know. Got to get my head back in there. Showing 0 volts, which means that that's grounded right now. So you guys watch the voltage while I move the switch. Follow me here with this diagram. Right now I'm in blower. Well, let's start with off. You see we have 12 volts. So what we've done is we've moved this switch that's inside to the off position. I've taken the ground away. There's also a green wire coming in here that is grounded from the HVAC module, not relevant to operation of the blower. It is, but it's not from a standpoint of blower controls. It's a signal to the module. So we're not worried about that one, the green wire. Ignore the green. In the off position, 1, 2, 3, and 4 do not have a ground. When I move to position 1, that voltage is gonna drop. Okay, move to position 2. Wait a minute. I need to think about everything I just said to you guys. I believe that 12 volts might actually, no, it can't be. Like, where's it coming from? It would be the blower motor itself. I'm concerned that maybe I didn't get a good voltage reading on the first white-black wire. I believe there's an open between the two white-black wires. That was my suspicions going into this, but I'm a little bit lost on this. If there's an open between the two white wires, which would be like, it's gonna be like in here, I think, between those two white blacks. If that's the case, I shouldn't have any voltage on the resistor circuit itself, but it might not be fully open in there. So the reason that we're seeing voltage on pin D, even though voltage stayed at 12 on pin C, the reason that we're seeing voltage on pin D is we're getting a stray through the burnt inside of there. That's what's happening. Because it can't be feedback from the green wire, because the green wire is grounded all the time through the switch. So it's not going to be that. This is another faulty blower resistor. The reason that we don't see corresponding voltage drops as I move this, because we should, like as I move the switch, we should see like high voltage on pin 1 because it's grounded. It's got to go through 3 resistors. So follow this in your diagram. This is my ground circuit. It'll go, if I'm in position 1, it'll go through here, and it's going to try to go here to 4. Can't go anywhere. The switch isn't connected. And then it'll try to go through 3. It can't go anywhere because the switch is not contacting 3. It's open in that section. And then it'll try to go there. It's traveling through 1 resistor, 2 resistors, and then on its way through 3 resistors to pin E, and then up to 1 on the switch to ground. And so what you would have on the white wire, which is where we're measuring, we would have a higher voltage than ground because it has to go through 3 resistors before it gets to ground. And then as you move the switch, each time you move the switch, then you're only going through, 2 resistors, and then 1 resistor, and then no resistor. So what you should have is, let's just say hypothetically, we should have 10 volts on the ground here, 8 volts on the ground here, 6 volts on the ground here. My numbers are off. And then, 0 volts, a true ground on 4. But I believe what we're seeing voltage-wise here, that the reason it's low on all of these is we're never passing the current flow for the blower through this because we have a burnt connector between the 2 white and blacks. And so it's just basically grounding, and that's why you're not seeing that voltage drop that I just described. Now, the question for us then is, did I do the first white-black wire correctly? We know the blower works. But did I measure the first black white wire correctly? So I'm going back to it. 12 volts on that guy. I just moved it over 1 pin, redoing this check. This, you're gonna see, this is gonna stay at 12 volts the whole time. So what that's telling me, again, is that we have a ground, our switch is working fine. We have a ground on the resistor bank through the blower switch, and that our problem is internal, again, between the 2 white black wires. So now I'm gonna pull this out. And then we have to address airflow. We have to address airflow. If this is burnt, we have to address airflow, and we have to address blower current. Okay? Where is the cabin air filter on this? Filter access door. I wonder if it's in there, Caleb. What do you think? Oh,
it's all dirt.
Oh, we got some leaves in there. It's dirty, but it wouldn't be dirty enough. You can see, let me hold it still. Can you see light through it?
Yeah.
I mean, it's absolutely dirty, but not, in my opinion, not to the point where it would burn up a resistor. I don't think. It's possible. It's pretty freaking dirty. But I mean, if this was like on a car, the fact that I can see light through that still, that's pretty bad though. Let's see what our airflow is. We're gonna ground this blower motor. I don't really like this as my ground, the pin, because of current flow. So I'm gonna switch this out. Let's see if I can get on the blower. Ground wire. Yes. And then ground it. And then what we want, I want to go here. I need your help here too, Caleb. Just put your hand there and kind of feel the flow of that, okay? And then circuit breaker resetting. So yeah, it didn't like that amperage through my power probe. That's all right. I'm gonna take this cabin air filter out and tell me, we can do amperage measurements here too with all of this, but it's just a practical test first. I would say there's an improvement.
Yeah, it's tough to say. I mean,
is it a marked improvement?
Do it one more time with it in.
Yep.
I don't know.
Nah.
No.
I want it, in my mind, I want it to be different because like that's our problem.
Yeah, it felt the same.
Yeah, it did feel the same to me too. All right, I need to unbolt that. We'll do current measurements, but I want to unbolt this resistor to show you guys what I was talking about it having a burnt circuit in there, in between those 2 white wires. Doesn't look burnt. Yeah. It smells burnt.
Didn't he just put a resistor?
Yeah, this is the part he changed.
Oh. Hold still. Dude.
So was I correct in what I told you about the 2 white wires?
I think so.
Well, that's the 2 white wires.
Oh yeah, it is.
And look where it's burnt.
Oh, it smells.
You smell it? Yeah. Yeah, it's cooked in there. All right, so what we want to do now, now it needs a connector. It needs a connector and a blower resistor. What we want to do is we want to ground this white wire here. The white wire that comes from the blower motor itself. I'm going to ground that, and then I want to measure amperage on what I'm grounding. So we'll get an amp clamp here.
Why are you measuring amperage on it?
I want to know what my blower amperage is, because too much current flow from that, if that blower motor is like failing,
yeah,
then we're too much current flow for this.
Yeah.
It could honestly just be a crap part. I'll have to ask Pete if this was burnt at all on the last one. It could also be that it had issues before. I don't know this, but if it was burnt before and then making poor contact equals heat. And so then what you have was a contact issue that caused this. So it's a couple things. A contact issue, poor terminal contact can cause that. Just loose terminals. Resistance equals heat. The second one would be, we addressed a plugged cabin air filter where this thing is not cooling properly. But in that case, you would expect to see, I would think, the burn in here, right? Not up in here. This is suggesting to me a terminal contact issue, or just poor design of the part where it's damaged up in here. But you're talking airflow is another one, poor terminal contact, or the blower motor itself drawing too much current. It is on a 40 amp fuse, so it's gonna have a lot of current flow. I can't tell you that I can give you a spec on like what the blower motor amperage should be, but we're gonna look at it, just covering all our bases. I think the motor's fine based on what it sounds like. I can't run it through my power probe for very long. Show you that again. White wire is gonna be this guy. And if I ground that, I think the blower motor's fine. I really do. I'm gonna get my amp clamp anyway. All right, amp clamp. Sharing my grounds. Going to my second channel. We're gonna go to the graphing meter. We'll go low amp 40. Amp clamp set on the 40. That just does the math for us. I'm coordinating the lab scope with the tool. If you don't have a lab scope that has that setting, you just use the math. Every 10 millivolts is 1 amp on that setting. Conventional theory flow, I'm backwards here. We can always flip it, but okay. And then I'll just use my power probe to ground it. It won't do it for very long. Whoops, wrong wire. Third one. Ready? Okay, pause that, zoom out. There's your blower. Initial surge in amperage up there. Let's go in a little bit more. Initial surge of current up here. Cursor 1, that's 36 amps up there. It's on a 40 amp fuse. It's very short amount of time that it's that high. And then that's typical of an electric motor. And then down in here, an average amperage of about 16 amps of current. And that's gonna be blower on high. I have no problem with that. So now I need to talk to Pete. Final thoughts, but I just wanted to get one more measurement here for you guys. It looks like this first one had even higher amperage, but it still doesn't bother me. Like this is good. Yeah, it's 40 amps on that peak, but it's like 16 amps after. So Pete told me that the resistor connector was not melted before. This is a new problem. This is kind of built in. So then we got to question the part itself. The part was aftermarket, and what I don't know is, are the pins the same thickness that a factory one would be, and we developed a connector issue? 17. I guess what I'm getting, I don't have a cause for you guys. You should do a cabin air filter on this too, Pete. I don't think the cabin air filter caused this. We measured flow, it felt good, it didn't feel any different. I don't think the blower motor caused this. So now we're left with either A inferior part, or B, we had a connector issue between the connector and the pins on this. That's it. And that's our issues. And we're changing a connector and this for the fix on this. You know, a 16 amp average with the blower on high. That's the most amperage you're gonna see is the high speed. 16 amps, that's not a problem. You're only talking about amperage that's in that real high range for delta time is 0.22 of a second. That's 200 milliseconds, guys. Between for that peak. And you know, to get down to like the 16 number, that's a half a second. That's not gonna cause that. Okay.
So you're not worried about the blower?
I'm not worried about the blower motor. Okay. If I was throwing parts at it, not doing measurements, and you know, someone could say, well, this is an easy video, like it's power grounds, you know, being the resistor was changed and the connector melted, change the connector, change the resistor, change the blower motor, change the cabin air filter. You wouldn't be wrong in going that approach. I don't think this blower motor caused this issue. You know, unless the motor, after a long period of driving the car and the motor starts making noises and slowing down, that's stuff that I don't know. So those are things you want to communicate with your customer for sure. But to me, this is, if it's my car, I'm doing connector, blower resistor, calling it a day. One last bonus for us, I don't have to put this cover back on.
That's Pete's problem.
It's Pete's problem. It's not my problem. Yeah. See you later.